So we're going to talk about 5.2, which is solving systems of linear equations by substitution. Now, substitution is something that you have actually seen us do in the past. A lot of times when we plug things in, like let's say we have an equation y equals 2x plus 3, and we want x to equal 4. Well, in this case, what we end up doing is we take this 4 and substitute it in for x to find our y value. So we have y equals 2 times 4 plus 3, okay? So then we just evaluate from here, going by our order of operations, which says multiplication first, which would mean y equals 8 plus 3. So we have y equals 11 as the answer when x is equal to 4. So this is a form of substitution, okay? What we're going to see today is we're going to substitute more than just a value in for a variable, okay? So let's go on today to example 1. All right, so let's start with example 1. We're going to solve the system by substitution. First thing I look at, I have a y equals this entire thing here. So what that tells me is, and this is already done for me, which is nice, this can be substituted straight in for y in that bottom equation. So I'm going to have 7x minus 2 times, in parentheses, what this is 2x minus 4 equals 5. Now, I used the red to kind of indicate where, or that was what was being substituted into that bottom equation. So now we have to use our distributive property and distribute that negative 2 through. So I'm going to get a negative 4x plus 8 equals 5. So now I'm going to have 7x minus 4x. This just gives me 3x plus 8 equals 5. My last step will be to subtract 8 from both sides, and I get 3x equals negative 3. Final step would be to divide by 3 on both sides. I get x equals negative 1. So now I go back and I want to plug this negative 1 into my top equation. It does not matter which one you do, top or bottom. It is completely up to you. I'm going to choose the top as I can. Okay, so I plug in that negative 1, and now I take 2 times negative 1, which gives me negative 2, and I just bring that minus 4 down, and then I have y equals negative 2 minus 4 would get me to y equals negative 6. So my final answer gets wrote as a coordinate point as negative 1, negative 6. And that is the answer you need to leave in. Here are the 3 problems that you can work on. Give you a second, and then you can pause the video, do them, and then check back towards the end, okay? Example 2, we're solving a system of linear equations. Now, in this case, we might need to solve for a different variable, okay? The thing I notice is my bottom equation, I can get y solved for pretty darn easily. So what I'm going to do is I'm going to subtract 5 to both sides. So I'm going to have 2x minus 5 equals y, okay? So now I have y equal to this, which I can now plug in to my top equation. So what we'll see is we have a 2x plus 3 times y, which y is equal to 2x minus 5 in this case. And that equals negative 3. Okay? So from here, we just use our distributive property and start solving. I have 2x plus 6x minus 15 equals negative 3. Combine our like terms, we have 8x minus 15 equals negative 3. Okay? All right, now we move on to start solving for x. I'm going to add 15 to both sides, and then that's going to cancel. I have an 8x equals 12. Divide both sides by 8. I have x equals 12 over 8, and I should reduce this to get a 3 over 2. Okay? So now I take this 3 over 2 and plug it in for x in either one of these. Doesn't matter. I'll plug it in the top one. 2 times 3 over 2 plus 3y equals negative 3. Now we just start simplifying and solving. So I have 2 times 3 over 2, which gives me 3 plus 3y equals negative 3. So I'm going to add or subtract 3, to both sides. That'll cancel. I have 3y equals negative 6. Divide by 3 on both sides. I get y equals negative 2. So now my coordinate point looks like 3 over 2, comma, negative 2. And that is your final solution. Okay? Give you a second to look at all of it. And then you got 3 more problems you can do on your own. I'll attach some answers for you at the end here so that you can double check your work. Please understand it is not just getting to the answer, but understanding how to get to the answer. So because there are answers back there, it is to help you see if you did this correctly, okay? Do not use that as a, hey, I did practice and just here's the answers, okay? It's there for an aid. Please use it as such. If you do have any other questions, please let me know. I did not include any answers for these on the back, okay? Other than that, thank you for watching the video. I appreciate it. Here are your answers.